In this video, I am going to discuss the most debated question of GATE 2026 Mechanical Engineering. This is a question where majority of students have given a specific answer, around 700, right? But official answer differs from that. It is around, I think, 572. So in this video, I am going to tell you which one is the accurate answer. And I am sure you know methods. Methods, you know that from which method you are going to get 572 and from which method you are going to get 700. Those methods you know. But which method actually is the correct one, and whether this question can be challenged, and if it can be challenged, then on what basis it can be challenged. So these are the things that I am going to discuss in this specific video. The question says that during orthogonal turning, this is the most debated word of this question. In orthogonal turning, by using a single point cutting tool, feed rate is given, alright. The uncut chip thickness is also given, and note that both of them are different. The shear angle, tangential force component and radial force components are also given respectively, and it is asking the value of shear force in Newton. First of all, those of you who don't have any confusion regarding this word, can simply proceed. I have already covered this concept in the course. This is the screenshot directly from the lecture where this force resolution Fy, Fx has been told, at this axial component has been told, and exactly at I think around 8 minutes in this question, 8 minutes in this lecture, I have specifically mentioned that in such questions you have to pay attention of what component has been given to you, because there are such PYQs in fact where axial force components were given, right? So specifically I have mentioned that, and in this question, rather than giving the axial component, Fx, they give the radial component Fy. So if you use that concept that I have covered in the video course, then you are going to get an answer which will be absolutely in the range, in fact almost midway in the range. I think this is the range right now as far as I remember, and using this method, you are going to get answer of I think 572 point something, which is almost midway of this. Alright, so the answer will be in the range if you use that method. But there is a debate about this word orthogonal, that if it is orthogonal, then these two should be same, why they are different, and so on. I will discuss those things. But before we get into that, right now we are going to discuss this, that exactly is there a debate, or is that a mistake, or is that a conceptual error, something that maybe you missed in the exam, or maybe from wherever you have covered this concept they have told you incorrectly. So let us first discuss that what exactly decides orthogonal cutting, the very basic thing. Don't get into this angle, that angle, inclination angle, side cutting edge angle. We will come to those. Just wait for a few minutes, we will come to those. Let us start to the most basic, the most fundamental definition of orthogonal cutting. And whether it is orthogonal cutting, orthogonal turning, orthogonal milling, anything is part of cutting only. Please realize, I have seen some students say, sir, orthogonal turning is something else and orthogonal cutting is something else. Sorry, I don't think you know this concept well enough. Orthogonal cutting is the major word under which every type of cutting comes, whether it is turning, whether it is milling, whether it is whatever type of cutting is there. So whatever is the basic of orthogonal cutting, that cannot be violated, okay? Whatever is the basic concept, basic fundamental of orthogonal cutting, what decides orthogonal cutting, that cannot be challenged, that cannot be changed, that cannot be violated. Whether it is orthogonal turning, milling, whatever you are doing, if it is orthogonal cutting, if it is orthogonal milling, if it is orthogonal turning, it has to follow the concept, the basic concept, the fundamental concept of what is orthogonal cutting. So to do that, to check whether students actually knew about this or not, I presented them this setup, this orthogonal or maybe oblique turning setup I presented, and I asked what type of turning is shown in the diagram. In this diagram, what turning you can see. I gave option of orthogonal, oblique, and can't say, depends upon inclination angle. Okay. Majority students ticked oblique. Majority students ticked oblique. Fluctuation kept happening, but this was the highest response. You know why? Because those students have understood or they have been taught that you look at this motion. This is feed, this is feed motion. You look at feed motion, and with respect to feed motion, at what angle this cutting edge is making, that decides whether it is orthogonal or oblique. That is a fundamental conceptual error. To decide whether it is orthogonal cutting or not, you look at the inclination of the tool with respect to cutting motion. With respect to cutting motion, or to be precise, with respect to cutting velocity, not with respect to feed motion or feed velocity. This is the most fundamental definition, most fundamental way in which orthogonal cutting is defined. On internet, if you just randomly search it on random internet pages, random blog pages, random books, even some books of not so credible publishers, they have not given this distinction. They have simply written that if this is the cutting, this is the turning happening, and this is oblique, simply oblique. No discussion about inclination angle. Do you think that orthogonal cutting is decided by side cutting edge angle? Is that the basic definition? Is that how you differentiate between orthogonal and oblique cutting? Then please go back to the very first lecture of orthogonal cutting from wherever you have covered and read it carefully. There are chances that also might have some mistake, because when I asked them that with respect to which motion we decide orthogonal cutting, then actually many of them said feed motion. It is wrong. Let me show you some proofs. Of it. This is in an Exergic video. In the very first lecture, you will see that. In the very first video of orthogonal versus oblique cutting, I have told every single time I have said cutting motion, cutting motion, cutting. Nowhere I have said feed motion. Cutting or cutting motion is going to determine, means the tool, inclination of the tool with respect to which velocity. So it should be perpendicular to cutting velocity, cutting motion. That's what I have said in the entire video, in the very first basic video of orthogonal versus oblique cutting, which you can check from these things as well. This is from IIT Mumbai. Cutting edge perpendicular to cutting velocity vector. Cutting velocity, not feed velocity. Cutting velocity vector. Both velocities are different. In turning, both velocities are different. This is your feed velocity. This is your feed velocity. But cutting velocity is here, perpendicular to the plane. If you look at this diagram, this is your cutting velocity. This is the tool is moving relative to the workpiece in this direction. But here, since tool is fixed and this is rotating, right? So if you look at it in the other way, then this workpiece, this material, this part which is approaching the tool, is approaching in this direction, along this direction. Getting? So this point, which is somewhat tangential, not axial. This is axial. Axial motion or feed motion is not deciding oblique or orthogonal. It is decided by this motion, which means, what does it mean? Let me give you a visualization here for those of you who have actually covered this concept from some other source and they have wrong concept. Let me give this clarity. If this is velocity of cutting, then this edge, this is the cutting edge, and this should be perpendicular for orthogonal cutting. And if this is not perpendicular, then that angle, this angle, is going to be the inclination angle. You see this edge, you see this edge, this should be perpendicular for orthogonal, or if not, if it is oblique, this will be inclined. So what will happen as a result of that? If this edge is inclined, so whatever chips are coming, they will move away from this place, right? Move away from where cutting is happening. And if it is not, then it will go in the orthogonal plane only. Another way to define it, that chips are going to flow in the orthogonal plane, which is perpendicular to it. That is slightly more complicated way to define it. That's why I am not going there and keeping the explanation simpler here. But this angle decides. this angle. Understood? And not this angle, not this angle. They are two absolutely different angles. It can be straight as well. Let me show you here. Let me show you here. This one. This angle, what you are seeing here, it is not inclination angle. You can't say that since this angle exists, so it will not be orthogonal. No, you are doing the mistake. You are looking at this angle with respect to feed velocity, which is wrong. And sadly, unfortunately, if you search on internet, 80% random internet blog, random websites, no credibility, and many random books, non-credible books also have written this only. They will simply show this diagram. They will say this is oblique cutting, this is oblique turning, this is orthogonal turning. Arey? Inclination angle decides whether it is orthogonal or not. Who told you that orthogonal or oblique will be decided by side cutting edge angle? That's absolutely wrong concept. Find me this concept. I challenge you, just go and find this concept in any credible source where they have written that side cutting edge angle decides orthogonal cutting or principal cutting edge angle decides orthogonal cutting. Find me one single credible source. I am not asking about random websites with no credibility, with no track record. Search in top 3, top 5 standard books in IIT modules in NPTEL. Can you find a single source which says that if side cutting edge angle is non-zero, then it will be oblique, or if side cutting edge angle is 0 or approach angle is 90, then it will be orthogonal. Then only it will be orthogonal cutting. Only then. No, that is not the deciding criteria. Yes, this situation is a part of orthogonal cutting. I will come to that. But that does not mean this is not orthogonal cutting. This also can be orthogonal cutting. How it will be decided? It will be decided by this angle, whether this angle is perpendicular or not. And from this diagram, you can't tell that. From this diagram, how can you tell whether inclination angle is there or not? This line, this cutting edge line, whether this line is like this or like this, that cannot be told from here. You either need to look at it from here, or you need isometric view, where you can see whether this cutting edge, which is tangential, whether that and these are at 90 degree or not. That decides the inclination angle. So this entire time I spent here in last few minutes was to clear the most fundamental point of machining, which is orthogonal cutting, orthogonal machining. What decides it? So please correct it. It is decided by inclination angle and not by approach angle, not by principal cutting edge angle or side cutting edge angle. I am not done yet. I know you have many questions in mind, because unfortunately you have not been told, from wherever you have covered this concept, you have not been told the right concept. And if you were randomly looking on internet, on random YouTube videos or some random internet pages, sadly most of them have told this concept incorrectly. That's why if you look at NPTEL or IIT or even standard books, you will get this right concept. So the very first thing, as I told you, cutting velocity vector decides this. This is another source from IIT Kharagpur. As you can see, this is VC, this is VC, this is VC, right? So if it is perpendicular to VC, then it is orthogonal, and if it is having some angle with respect to VC, you see that this angle, this is the angle which is making with respect to VC, not with respect to feed velocity. That is the basic difference between orthogonal and oblique, not by side cutting edge or any other angle, but by inclination angle. This angle is the inclination angle, right? And as I told you, same thing I have told you in a much simpler way. Without this may look very intimidating or confusing to you. I have covered this in the first lecture of orthogonal versus oblique with a hard board in my hand. I have shown that, and every single time I have said cutting motion. Nowhere I have said feed motion, right? So we are not done yet. There are so many things to discuss interesting points to cover here. That's what I have written here, right? That's what this question says. That's what this is poll that I conducted says. That you can't say. This diagram don't even tell you what is the inclination angle. So you can't tell. It depends upon inclination angle, right? And inclination angle can only be seen not from this diagram. From this view, how you can tell whether it is like this or like this or like this? You can't tell that. You can only tell that if you look at it from here, or in the isometric view. Or if question gave you some data. Question did not give you any diagram. Question has not given you any diagram. So how did you decide? You have to look at the data. That's the point. You have to look at the data. You cannot say that orthogonal is written, so I will reject the data. Data only will tell you whether it is, what type of orthogonal cutting is there. I'll come to that. Just wait for a minute. I'll show you each and every PYQ as well from this topic. Don't worry. So, yeah, this point I think I already touched upon. Inclination angle is not side cutting edge angle, right? Orthogonal turning or orthogonal cutting or orthogonal milling, grinding, whatever you want to discuss is decided by this, not by this. So, a question comes to mind that, sir, what about this then? What is this? If you are saying that this can be also orthogonal, this also can be orthogonal, so how do we decide? What is the differentiation between these two cases? Look, if both of them I am saying are orthogonal, firstly realize, if I am saying both of them are orthogonal, so one thing is for sure, that inclination angle is equal to 0, right? You might have used lambda for it in your course or whatever other sign you have used. I have used I, so that's what I am writing here. Inclination angle is 0. Suppose I know that both of them are orthogonal, so their inclination angle is 0. Means this one, to chalo, all of you are agreeing upon, but this one here means that this line here is perpendicular to this tangential vector. Got it? So how do you differentiate between these two? These are the two types of orthogonal turning cases, orthogonal cutting cases. This one has a side cutting edge angle, and this one side cutting edge angle is 0 or approach angle is 90. In this one, side cutting edge angle is not equal to 0, and that's why lambda is not equal to 90. In fact, this type of orthogonal turning has a special name which is called as true orthogonal turning or pure orthogonal turning. Don't believe me? Firstly, have a look at this again. IIT Kharagpur, correct? Orthogonal cutting. Both of them have been shown as orthogonal cutting. In fact, the main explanation of orthogonal cutting has been explained using orthogonal turning. I encourage you to search on YouTube. You will find this video. If you need the link of this video, please email me. I'll share the link as well. So this has been explained as primary example of orthogonal cutting. Means orthogonal turning has been explained as the primary example of orthogonal cutting. Same logic, that here in this direction chips are going to flow. Means basically this vector and this line, this velocity vector perpendicular and this line, they are perpendicular to each other on that basis only. But this case where this angle is 0, you see here this angle exists, but here that angle is 0. That has a special name. Go check this lecture out. That has a special name of pure orthogonal or true orthogonal cutting. In fact, this is something, now you will say, oh sir, suddenly you are saying this. I have covered in the course. Especially I have mentioned that in these cases, both the cases I have shown here, right? You can see that this one and this one, both the cases, what is true? I is equal to 0. That is true for orthogonal cutting. Here is just a screenshot. So I am explaining what is there in the video. Those of you who have the access of Exergic video course, please go and check out this video. So orthogonal cutting means this condition, I is equal to 0. But when both the conditions are satisfied, then it is called as true orthogonal cutting or pure orthogonal cutting. Specifically, I have mentioned these two cases. Both of them are under orthogonal cutting if their I value is equal to 0. And this case is a special case which I have mentioned here, which I have summarized here, that for true orthogonal, both of these conditions needs to be satisfied. In fact, GATE has asked such question where you can see that in a pure orthogonal turning, right? What case they are referring to? What is pure orthogonal turning? You might ask, if you don't believe that there are two types of orthogonal turning possible, if you think that no sir, orthogonal means this only, then what is pure orthogonal turning, right? Actually this is a subset. Two types of orthogonal turning are possible, right? If this condition satisfy, then it is pure orthogonal. And if only I is equal to 0, then it can be this also, that also, both of them. Then data will tell. If only I is equal to 0 is there, means only orthogonal is written. If only orthogonal is written in the question, if only orthogonal is written in the question, then how do you decide whether it is this or this? Data will tell. You can't say that no, question has mentioned orthogonal, so only this will be true and rest data is incorrect. Data is the only thing which is helping you differentiate between these two cases. That it is orthogonal means I is equal to 0, understood. But which of these cases should I take? Whether I should proceed by that case or this case? Then data only will tell you. What students right now are saying? That orthogonal is written, so why this data is given, why they are different, that cannot be the same. Why radial is written, that cannot be the true. That is what is telling you that in this question, this orthogonal case has been given. In this question, this orthogonal case has been given to you, where side cutting edge angle is coming into the picture, right? Where feed and the chip thickness that is coming out, they are not same, because this exists, this is non-zero. This is non-zero, right? Radial force is coming into the picture because this angle exists. So the most fundamental mistake, which I am telling you, it is surprising to see on the internet, that if you randomly search it on Google, you will find 90%, maybe more than 90% websites who are simply saying that if this is this case, if this is the diagram, it is oblique. They are violating the most basic definition of orthogonal cutting, that it is not the side cutting edge angle or principal cutting edge angle that decides orthogonal cutting, it is the inclination angle. And this view does not even show you the inclination angle. So how you can decide? It will depend upon the inclination angle, and that's why you need to look at the other data. Got the point? I am coming to PYQs. I know there are some PYQs which you feel are confusing, so I'll come to that. So, as I was telling you, that pure orthogonal cutting, true orthogonal cutting, ideal orthogonal cutting, all of these names, right? Like true orthogonal cutting, pure orthogonal cutting, all of them refer to this specific case. Now, one example of pure orthogonal cutting, another example, pure orthogonal turning, right? This specifically is telling you about that situation when lambda is 90, side cutting edge angle is 0. Now, this question. In this question, some students are having doubt that, sir, here orthogonal turning is written, and in this question, they have taken the same approach, that side cutting edge angle is equal to 0, right? This case they have taken. This case they have taken, side cutting edge angle is 0, or this case they have taken. So how do we decide, sir? I am repeating, read the question data, that will tell you. In this question, it is not possible to find out side cutting edge angle. You will not be able to solve this question. You will have to assume it as pure orthogonal turning. In fact, this gives you the hint, it is a steel tube. And for tubes, this is what we use. For tubes, look at this is tube. For tubes, that is the type of turning that we do. I know it sounds different, because you may say, pay attention, what I am telling is very important. You may say, sir, if we are using this tool here to turn a tube, but sir, for turning, diameter should decrease. That's the generic way of defining, that turning means diameter is decreasing. Facing means length is decreasing. But that's not the perfect definition. Perfect definition is how the tool feed is given. That's where feed comes into the picture. If feed is in this direction, that is turning. If feed is in this direction, that is facing, right? So turning can also be used to reduce the length. Pay attention to what I am saying. That's why this video is going to give you small nuggets of knowledge. In this case, if it is a tube, it's a thin tube, right? You just align the tool with no side cutting edge angle and you just give it this feed. So what essentially tool is doing? It is the feed motion. For feed motion I am saying cutting is happening like the way only, like this way only. Cutting is happening like this way only. I am talking about feed motion here, right? Which does not decide orthogonal or oblique, which decides whether it is going to be turning or facing. So here, even if you give it the feed motion, it is turning, but it is reducing the length. How? Because beach mein sab hollow hai na, here everything is hollow. You don't need to remove anything from there. Generally, if you do turning, this part needs to be dealt with, but center is hollow, it is tube. So you only need to work on the periphery. So even this motion, even the feed motion, which is turning motion, axial feed, that itself, which is turning, that itself is reducing the length. So if a question comes tomorrow in GATE, means next year, that to differentiate between turning and facing, what do you use? So yes, that is a generic answer, that turning reduces diameter, phasing reduces length, but that is not the perfect definition. Perfect definition is decided by the feed of the tool. If you are giving axial feed, then it is turning. If you are giving it a radial feed, then it is facing. So coming back to what I was telling, what I was discussing, that in this question, you have been given a tube and you are turning a tube. Means what? Means it is this case only, is this case only. Tubes are not turned at some angle, at a certain angle. They don't have a bulk of the material in the center, which needs to be moved out. It's just very thin tube. Generally, I am not saying it is true every time. It depends upon the question. Generally, tubes are machined like this. Or if I show you a clear diagram, tubes are machined like this. Or if I show you another diagram, tubes are machined like this. Why? Because most of the material is here on the periphery, right? So just a single motion, angle has no value there, practical value there. That is why generally it is true. Again, I will repeat, it is not a rule. It depends upon the question given. If in the question given, side cutting edge angle has not been given or no data has been given which can find out side cutting edge angle, what option do you have? Will you start questioning this? They should have mentioned pure orthogonal only. Arre, that is orthogonal only, bhai. That is orthogonal only. This cutting or this turning is orthogonal only. Both of them are orthogonal only. Sometimes question will mention orthogonal as a language of the question, like they have done in this case. You have to figure out which one is this. Sometimes they will just simply write true orthogonal or pure orthogonal. So it depends upon the question. Does not mean if question has to write pure orthogonal or true orthogonal, only then it will be used. No. If it is orthogonal and it is satisfying the rest conditions, means you have not been given anything from which you can find out side cutting edge angle. Or side cutting edge angle has not been given to you. Nothing has been given which suggests that this angle has any value, has any significance. Then this is the only way that you solve it. Let me explain that to you in a slightly different manner. Suppose the big category is apple. Big category is apple. Okay. And there are two different colors in which apple are being sold. One is green, another is red. One is green, another is red. What you are doing currently, you are saying that if question mentions apple, it has to be red only. No. Question can mention apple, question can mention orthogonal. But whether it is true orthogonal or not, that will be decided by its color. Means you have to look at the given data, given characteristics to decide whether it is red or whether it is green. But you can't say that if it is question has mentioned apple, it has to be red only. That is the fundamental flaw, and the reason of that flaw I just explained to you. Because from wherever you have covered, at least not in Exergic, I have not said this. Never ever I have, as I showed you, go and check orthogonal oblique cutting lecture, go and check this lecture, and go and check this lecture. I have kept this distinction, I have explained this very clearly, right? But somehow from wherever you have covered, you got this wrong idea in your mind that this picture is oblique. In fact, again I am repeating, I don't know, third time or fourth time, majority of the random internet blogs have written this only. They will show this and they will say this is oblique. No credible source. Email me, email them, ask them the proof. From where did they find it? No proof. Every single credible source, IIT Bombay, IIT Kharagpur, every single credible book has a clear way of defining orthogonal cutting which is through inclination angle and never through side cutting edge angle or approach angle. Got it? So, not done yet. There is, I think, a couple of more questions to discuss. Now, this question is being shared that here in orthogonal turning, look, orthogonal turning is written and it is written principal cutting edge angle is 90. So, orthogonal turning has to have principal cutting edge as 90. No, it tells actually the opposite. It gives you the condition. You missed this word, if. There are two types, repeating again, two types of orthogonal cutting. It is giving you a data कि for this orthogonal turning, take that one where principal cutting edge angle is 90. Same thing in another question. In orthogonal turning of low carbon steel, principal cutting edge angle is 90. What you are saying? That if this is true, this has to be true. If this has to be true, why is this given in the question? They have given that orthogonal turning are of two types. The one we are discussing here is with this angle, is with principal cutting edge angle. Orthogonal turning are of two types, This is the one that we are discussing where principal cutting edge angle or side cutting edge angle or approach angle, whatever they are going to give you, they are using that data. They are using this data to help you differentiate that what type of orthogonal cutting, that this type of, if, when, all these terms are telling you the specific case where it is true orthogonal or pure orthogonal cutting by giving these values, Understand? So, the basic thing here is to read the question carefully. If you are just looking at 3 PYQs, from where do you conclude this? From where do you conclude what is orthogonal, what is not? Right? So, what you are doing currently is maybe looking at those 2-3 PYQs, and since your basics have not been covered properly, basics of orthogonal versus oblique have not been covered properly from wherever you have covered this topic. So, you are highly likely to make wrong conclusion because your basics itself have not been properly explained to you from wherever you covered this topic. And that is the source of your confusion. It is quite possible that even after understanding all this, some of you will say, no, sir, this is not how it is. No, sir. This has to be orthogonal, sir. This has to be orthogonal, sir. It is possible because you have not covered things from the basics. Whatever you have been told or covered from wherever, that was surface level knowledge without getting into how inclination angle works in turning. You were only told those 3-4 angles in turning. You were only told those 3-4-5 formula and look at the data, put the formula, get the answer. You were never told the value of inclination angle from the point of view of turning, and that is why you are having this confusion. So this video is not going to clear everything for every one of you. I am sure some of you will understand what I am trying to convey, but a lot of you whose basics are sort of broken, have not been properly put together, they are going to struggle to accept this, because for that you need to cover everything from the very first basic lecture of what is orthogonal, what is oblique, what is feed, what is cutting, how do we decide inclination angles, what different planes are there, right? So when you start from the basics, then you will gradually realize what exactly is there. Coming to final point, whether you should challenge this question or not. Firstly, I think conceptually what I told you in the video course is giving you 572 point something answer, correct? As I have, I think, showed you as well. So those of you who actually listened to the video, especially at the 8th minute, I have mentioned that as well. So those of you who paid attention, and even in PYQ such questions are there, in PI PYQs, not in mechanical, in PI PYQs, production engineering PYQs. So those of you who paid attention, I think they are getting the answer in the current range only. So why would they challenge? They won't challenge. Those of you who are getting a different answer, which is 700, which is happening when you don't pay attention to any of this, you simply take this radial force as thrust force, which is not the case. This is thrust force, this is radial force. Both of them are different. So those who are doing that, they are getting the 700 answer here. So conceptually, 700 answer does not hold true. That is not correct conceptually. But I understand that challenging a question is not just about conceptual clarity, right? I am sure all of you know that. Because when it is challenge, when it is about challenge, it is purely a transaction from the point of view of your marks. If you see that if a lot of us challenge the question, and that may make IITs change it, please go ahead and challenge it. Ideally, my view is, I'm telling you very raw opinion in this video, very raw opinion even about challenging. If you think a question can be challenged, even if it has 10% possibility, 20% possibility, I will say challenge it. If 500 rupees doesn't matter much for you, in the long run, I don't think they matter a lot in the long run, in 10 years of time, right? Today, if you think about your past 5, 6, 7 years earlier life, if you would have spent 100, 200 rupees extra somewhere, I don't think you are regretting that at all. But this is a very important part of your GATE final result. So if you feel, no, this is wrong, that should not happen. Whatever logic you have seen, maybe the PYQs, as I told you, in the PYQs also, I showed you the PYQs, right? You are not able to see what I am trying to explain. Why I explained that? Because fundamentals are not in right place. So it's all right. Right now, you don't have to focus on this. Right now, you have to focus on challenge and getting more marks if possible. So I am not here to discourage you from challenging this question. You go ahead and challenge the question. But I have told you what is conceptually correct. And maybe they will accept the challenge. Who knows, right? Maybe they will contradict their own, what they have said, right? Their own lectures, they may contradict. And they may accept the challenge. Right? Who knows? Which was the third image? This one, right? Clearly has mentioned both of the cases are under orthogonal cutting. This one is also orthogonal, this one is also orthogonal. Depends differentiation between them, whether it is true or not, that is decided by side cutting edge angle. But main orthogonal cutting, how do we decide orthogonal cutting versus oblique? The basic difference, that is done by inclination angle, not by side cutting edge angle. So they may go ahead and violate their own different lectures, right? So that if happens, nothing can be done about it, right? Because there are certain cases which are not in our control. There are certain variables which are not in our control. Maybe possible if they just challenge, if you challenge, they accept and they agree that chalo bhai 700 also is the correct option, we will take that. Maybe you got confused, maybe this orthogonal word confused you, chalo, we will give it to you, take the marks, possible. So don't hold yourself back from challenging just because someone said or I said that chances of challenge are less. Even if it is 5% chance, 10% chance, go ahead, challenge the question. And you can use these PYQs if you want. You can use these PYQs for challenge, right? I'll tell you that you can show these PYQs. That's how I understood that it means that if it says orthogonal, it has to be this case. It can be your interpretation, which is conceptually wrong, conceptually incorrect. But right now, you may keep concepts aside and just focus on marks, getting 2 marks more. So you can say that in this question, I thought orthogonal cutting means it has to be 90. You can mention that. Maybe they will accept it. Maybe they will think, oh, so many students got confused this time, let us give them the marks. I don't know how that works. Honestly, I don't know how that decision works, because in many previous cases, so clearly wrong questions were also not changed. They were also not changed. And some not so obvious things got changed. In some random question, range got increased, which was not asked by a lot of people. So I can't say that, yeah, I know how this works and everyone challenge and do this and that will happen. I don't know how that works. And neither am I interested. My interest is towards the conceptual things and not about these operational things, right? So still, I can just tell you that please go ahead if you want to challenge. I have showed you, I think, last a couple of questions using which you can tell that my understanding from this PYQ was that if orthogonal mentions, it has to be the case. Principal cutting edge angle should be 90 or side cutting edge angle should be 0. This was my understanding, which is violating with this question. So that's why I think you should also consider 700 as the correct answer. And I wish you get the marks. What I have to lose here? Nothing, right? If you get such marks, it's going to be better for you only. So I have no inclination. My inclination angle is 0. I am orthogonal here. My inclination angle is 0 towards any specific answer. Only thing here is conceptual clarity, which I gave you, and conceptually I told you this is wrong and this is the correct answer for this question. All the best.